Good morning, dear students. My name is Ferhan Mazher, and today is 23rd of October 2021. The day is Saturday. Right now, I am working with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O-Levels Physics, and today we have set our hearts to solve May-June 2020 4-1 paper. It's an ATP paper. We call it Alternative to Practical. We also call it Paper 4. And in this paper, the time allowed is 1 hour, and this paper belongs from the zone 1 or the variant 1. So let's start this paper and hope for the best. So the paper we are working on is May-June 2020 4-1 paper. A student has two measuring cylinders. One cylinder contains water and the other cylinder contains ethanol as shown in the figure 1.1. So this cylinder has water in it and this cylinder has ethanol in it. Write down the volumes of water and ethanol in the measuring cylinders shown in the figure 1.1. So if you check what's the reading here and what's the reading here, so you can tell the volume of the water and you can also tell what's the volume of the ethanol. So let me show you my work, and from there we will check the readings. So if you look at here, this is 40, 41, 42, 43, 44, 45. So the volume of the water is 45 centimeter cube. For ethanol, it's 41, 42, 43, 44, 45, 46, 47, 48. So the reading for the ethanol is 48 centimeter cube. So the next question coming up, that's the B part of the question number 1. And its first part, he says the student then pours the ethanol into the water and allows the liquids to mix. There is no chemical reaction. Figure 1.2 shows the volume of the mixture. Use your answer to the A part to calculate the total volume of the water and the ethanol before they are mixed. So the total volume of the ethanol and the water, because you have poured the ethanol into the water, so the total volume we think should be 45 plus 48, 93 cubic centimeter. Then he says, write down the combined volume of the mixture as shown in the figure 1.2. So the combined volume. So here you can see this is 90 and this is 1 below the 90. So it will be 89. So according to the figure 1.2, the combined volume of the water and the ethanol is 89 centimeter cube. So that was the question we were working on, B part. Now we have the question number 1, it's B part, and that's second portion. He says, suggest one possible reason for the difference between the two answers in the B first part. You see, we thought that the volume of the mixture will be 93 cubic centimeter, but in reality, the volume of the mixture was only 89 centimeter cube. So the one practical reason can be when you pour the ethanol into the water, you see some of the ethanol will remain in its cylinder. Some of the ethanol will keep in the form of droplets, which the droplets will be sticked with the walls of that cylinder. So some of the ethanol has remained in its cylinder. Another reason can be that when you are pouring the ethanol into the water, some of the ethanol might have spilled. Okay, so let me show you my answer, and from there, okay, some ethanol is left in its cylinder in the form of droplets on the walls of the cylinder. That can be a reason. The other reason I told you can be that when you were pouring the ethanol into the water cylinder, so some ethanol might have spilled on the ground or onto the table. The C part is the second student says that the result after mixing must be incorrect. State what the first student does to check the data. So very simple thing is that he can do the experiment again. So he repeats the experiment. So if he repeats the experiment, he can verify that if this thing is incorrect or correct. So that was question number 1. We are done with the question number 1, and let's have a look at this marking scheme. So my dear students, the marking scheme of the question number 1 is showing up on your screen, and I always tell you that it's very important to check your answers and match them with the marking scheme. So what you can do is you can pause the video and take your time to have a good look at this marking scheme. Question number 1 marking scheme is showing up. So let's move to the next question. The next question coming up on your screen is question number 2. So he says a student investigates the time taken for a glass ball to roll down a slope. She uses 2-meter rules placed side by side with a small gap between them to make channel along which a ball can travel. A stack of identical sheets of paper is placed at one end to create the slope as shown in the figure 2.1. So what they have done here, they have used 2-meter rules and make a channel so in a ball can roll through them. And here they have put a stock of sheets of paper. So this ramp can be made, or this slope can be made. The height of the slope is changed by changing the number of sheets of paper in the stack. The slope is 100 centimeter long on the figure 2.1. Show the position of the ball when it has traveled 100 centimeter down the slope. So this channel is 100 centimeter long. So these are those papers. And when the ball will roll and it has covered 100 centimeters, the ball will be here. So I will show a ball here. So let me show you my answer. So you can see here, that's question number 2A, first part. I have shown a ball here. So you can see this ball here. So when the ball has rolled 100 centimeter along this slope, the ball will be here after covering the 100 centimeter at the edge of that incline. Okay. So the next question coming up on your screen. Let me show you. A paper stack is made from 20 identical sheets of paper. A student uses a micrometer to find the height age of the stack. The micrometer reading is shown in the figure 2.2. Write down the height age of the stack. So we have to write down the height here. So you know how we use the micrometer is very simple. First of all, we check that how much this has traveled on this horizontal scale. This is 0 millimeter. This is 0.5 millimeter, 1 millimeter, 1.5 millimeter. This is 2 millimeter. So on the horizontal scale, 2.00 millimeter. It has traveled how much? 2.00 millimeter. Then I will check that this circular scale, which line of the circular scale is exactly coinciding with this horizontal line. On this circular scale, I will check that which line coincides with this horizontal line. So it is this line. So this is actually 14. So we will write 2.00 millimeter on the horizontal scale and 0.14 on the circular scale. And then I will add them. That will be my answer, and that will be 2.14 millimeter. 2.14 millimeter. Let me show you from here. So you see on the horizontal scale, you have 2.00 reading, and the 14th line on the circular scale is coinciding with this main horizontal line. So it will be 0.14. So you add them, it will be 2.14. So the reading is 2.14 millimeter. 2.14 millimeter. Okay, so the B part of the question number 2 is the student then uses a stopwatch to find the time taken for the ball to roll from the top to the bottom of the slope. She repeats the reading and gets the following values. So you have to pay attention to these values. The first value is 8.45 seconds, then 8.54 seconds, then 8.47 seconds, and then 5.85 seconds. And the last reading is 8.46 seconds. If you pay attention, you will see that this reading is totally different. The rest of the readings are close to each other, but this reading is very different. So just reject this reading. Ignore this reading. He says, explain, that's the first part of the B. Explain how the student uses this data to find the average time taken for the ball to roll down the slope. So what we will do, we will ignore this value because it's too much different. I will take these 4 readings and I will add them and I will divide their sum with 4. So ignore 5.85, add the rest of the observations and divide their sum with 4. Then the second part is, he says, calculate the average time taken for the ball to travel down the slope. Give your answer to 2 significant figures. We have to write the answer in 2 significant figures. So I will add 8.45 plus 8.54 plus 8.47 plus 8.46 equals to, divided by 4 equals to, and my answer will be 8.48. Now 8.48 has 3 significant figures, 8, 4, and 8. But they asked us to write the answer in 2 significant figures. So I will round it off and it will become 8.5. So now 8.5 seconds is the average time and it has 2 significant figures. Then we have the third part. He says, explain why an answer to 2 significant figures, an answer to 2 significant figure is more appropriate for the average reading in this case. You see, the readings, they have variation in them. So, for example, the one reading is 8.45, the other reading is 8.54. So it cannot be accurate. So our answer cannot be more accurate than 1/10th of a second of a second. Okay, because there is very large variation in the raw data. So it's sensible to round into 2 significant figures. Answer should be rounded off to 2 significant figures because the given data has larger degree of variation. Fourth part is, he says, use the equation average speed is equals to the distance divided by average time to calculate the average speed of the ball on the slope. give the unit of your answer. So the distance the ball traveled is 100 centimeter. The time taken is 8.5 seconds. So on your calculator, divide 100 divided by 8.5, you get 11.76. But if you round it off to two significant figures, it will be 12, and the unit will be centimeter per second. 12 centimeter per second will be this thing. The C part is, let me go to the paper and show you. So this was what we were working on. That is that question. Over here, C part. The student extends the experiment and changes the height of the slope by increasing the number n of the sheets of paper used in the stack. She finds the average time t for the ball to roll down the ramp for different values of n. The results are shown in the table 2.1. So in the table 2.1, you can see here we have, and in this fill in the blank, you have to put that average time, which was 8.5. Okay. Using the data from the table 2.1, draw on the grid in the page 2.3, in the figure 2.3, sorry, a graph of average time t on the y-axis. The time will be taken on the y-axis, and against the n on the x-axis. N is the number of papers, and that should be on the x-axis. He says start your axis from 0,5 as shown. Draw the best fit curve. So 4-mark question. So let me show you. This is the grid which is given to us. Let me reduce the size of the grid. So this is the grid which is given to us, and we have to draw the graph. And on the y-axis, we will take time, and on the x-axis, we will take the number of papers. Sorry. So this is how you do question number 2C, first part. You can see this table, and this time will be represented on the x-axis, and you have to label this. Sorry, I said x-axis. It's y-axis, time in seconds, and on the x-axis we will represent the number of sheets of the paper. So the n here on the x-axis, the number of sheets goes from 0 to 140. So you can see here 20, 40, 60, 80, 100, 120, 140. The time is going from, the minimum time is 5.1 and the maximum time is 8.5. So what I do, it's starting from 5. So 6, 7, 8, 8.5, 8.75. Okay. So this is how I have put the grid. I have used my scale. Okay. Now we will plot those points. You see, for plotting those points, you can see this is the x-axis, this is the y-axis. So 20, 8.5, 40, 7.2, 60, 6.2, 80, 5.8, 100, 5.5, 120, 5.2, 140, 5.1. So the time is here and the number of papers are here. So we will plot these points. You can see here I have plotted those points. Okay. So you can also plot if you have the hard copy of the paper with you. So plot these points, locate these points on the grid, then join them with the smooth curve. I have tried to draw a smooth curve. And when I draw the smooth curve, the smoothness is important. It's not important that the points are joined. For example, you can see this point and this point, they are left. But we have tried to keep the smoothness of the curve. So this is how you will join that curve, the points to form a smooth curve. Then he says, state the relationship between n and the average speed of the ball. This question is of 1 mark, but it's very tricky. You see, this graph is between time and the number of papers n. And normally, wherever the question comes right after the graph, you have to tell the relationship from the graph. But the question here is about the number of papers and the speed of the ball. You see, as the number of papers are increasing, to cover 100 centimeters, the ball is taking less time. Try to understand this point. When the number of papers are becoming more and more, that slope will become steeper and steeper, and it means that the ball will take, according to the graph, when the more number of papers are used, the ball takes less time to cover 100 centimeters. So it means when the n is increasing, the speed of the ball increases. This 1 mark is not easy to get, because it will confuse the student. He asked the question about the number of papers and the speed of the ball. So the D part is the second student carries out the same experiment, but she does not have access to a micrometer. Explain in detail how she can find an accurate value for the height of the stack of 20 sheets using a meter. So you see, if you don't have a micrometer, so you cannot directly measure the height of the 20 papers. So what you will do, you will put 100 papers. For example, you put up and down 200 papers. Put 200 papers, then use a meter rule, find what's the height of that stack, and divide that height with 200, and then multiply it with 20. So you will get the height of the 20 papers. Find height of 200 sheets, then divide the height with 200 and multiply with 20. This will give you height of 20 sheets. So my dear student, that was question number 2. It was of 15 marks. So let's have a look at its marking scheme. Okay. So the marking scheme of the question number 2 is showing up. What you can do is you can pause the video here and have a look at this marking scheme. Very, very important task is to always check the marking scheme. These are the last 2 parts of the question number 2. Pause the video and have a look at them. Okay, so we are moving to the next. Okay. A student makes a periscope using cardboard tubing and mirrors. He looks through the periscope at a flower as shown in the figure 3.1. 2 rays of light are shown going from the flower to the mirror 1. Complete the ray diagram in the figure 3.1 to show both rays as they reflect at mirror 1 and then mirror 2. Draw an arrow on each ray to show the direction in which the light is traveling. So we are talking about this diagram. So this is the mirror 1. From here they will be reflected, from here they will be reflected, and they go into the eye, the light. So let me show you my work. I've done this paper. I've done this question. So you can see that with the red light, red color, I have shown when it will be reflected from here and then reflected from here and go into the eye. This ray reflected from here, go into the eye. One thing is very important, which I want you to understand. You see, this is the top for example, this is the top of the flower. And the ray which started from the top is coming at the bottom. This is the bottom of the flower. And its ray, when reaches the eye, it is on the top. So it means that the image of that flower will be inverted. It will be upside down. Okay. The next question coming up is, let me first of all show you from that paper. So that he says the next part is, he says, draw, third part is figure 3.2 shows the original flower. On the figure 3.2, sketch the image of the flower as seen by the student through the periscope. So he will be looking at a flower. The image of the flower will be upside down. So this flower will be down, and this stack and these leaves will be on the top. So I have tried to draw that image. We are not very good at drawing the images, but we have tried our best. So the image he sees will be something like this. You can see it will be upside down. So we have tried that the same size is just upside down. So I have tried to keep the size of the flower same. It's very important that the size of the flower with the naked eye inspection should look like same. Okay, so let's move to the next part. He says a second student. This question came first time where you have to actually draw an image, sketch an image. A second student also makes a periscope. Her periscope is shown in figure 3.3. State how the image of the flower seen by the second student differs from that seen by the first student. You may draw the rays on the figure 3.3 if you wish. So we will draw these rays, and then you will see what's the difference. So let me show you. So you can see this ray reflected from here, comes here, then goes into the eye. This ray comes here, reflects, and here reflects and goes into the eye. So this ray which started from the top of the flower is also coming to the top of the eye. This ray which started from the bottom of the flower, after reflection comes to the bottom of the eye. So the student will see an upright image. The student will see an upright image, whereas in the first image which you saw, the student, the image was upside down. So that's the main difference. Image seen by the second student will be upright. So my dear students, we are done with the question number 3. So let's have a look at the marking scheme. Okay. So on your screen, the marking scheme of the question number 3 is showing up. Pause the video and take your time to have a good look at the marking scheme. It's very, very important. Okay, so we are starting the next question. That's question number 4. He says a student is given 2 closed boxes. One box contains a fixed resistor and the other contains a filament lamp. The student is asked to identify the contents of each box. Figure 4.1 shows part of the circuit used to identify the contents of each box. So here in this circuit, we have batteries, then we have ammeter, here we have the voltmeter. Their question is figure on the figure 4.1, show how a box is connected in the circuit so that the current through it and the potential difference across it may be measured. Use the symbol this for the box. Okay, this is the symbol for that box. Inside the box, maybe we have filament lamp or maybe some other thing, but that's inside the box. So how I will put this box? I will take this and I will put it here. So you put that box like this because this voltmeter will be parallel to this and the current will flow from here. So the ammeter will be able to read how much current is flowing through that component. Then the B part of the question number 4 is the student now uses his circuit to identify the contents of the boxes. Describe how he uses the circuit. The first part is the number of cells used can be varied. Okay, so if the number of cells can be changed, when you will change the number of cells, you see what will happen. The reading on the ammeter will change, the reading on the voltmeter will change. So for example, he put 2 cells and note down what's the reading on the ammeter and what's the reading on the voltmeter. Then he will keep the same thing, everything same, but he will put then 4 cells and then switch on the circuit and he will note down what is the reading on the ammeter and what is the reading on the voltmeter. And then he can put there 6 cells and then switch the circuit on and note down how much is the reading on the ammeter and how much is the reading on the voltmeter. So place the box in turn in the circuit and measure I and V. Change the number of cells and measure again I and V for both boxes. For example, you put a box there in that circuit and you note down what is the reading on the ammeter and what is the reading on the voltmeter. Just note it down, and number of cells also. And then change the number of cells. And again switch it on and note down what is the reading on the ammeter and what is the reading on the voltmeter. Then he says state the readings that he takes. Oh, he will be noting down how much current is on the ammeter, how much voltmeter is showing the voltage drop. And another thing he can note down is that how many cells he's using. For example, he's using 1 cell, 2 cells, 3 cells, 4 cells, 5 cells, 6 cells. He notes current I and voltage drop V, and he also counts number of cells. Now the third part is, he says, explain how he uses his readings to decide which box contains the filament lamp. You see, the filament lamp is a non-ohmic conductor. Filament lamp is a non-ohmic conductor. So if you make the IV graph for the filament lamp, that graph will be a curve. But if you draw an IV graph for the fixed resistor, it will be a straight line. So, so very simple. Plot the graph of I versus V for both boxes, whose I and V graph is curve is filament lamp. So for both of the boxes, draw the IV graph. Take the different values of the current and voltage by changing the, when you change the battery, when you change the source, you see the I and the V value will change. So for both the box number 1, box number 2, one box has fixed resistor, the other box has filament lamp. Note down the reading. Note down the reading on the ammeter, voltmeter, and then you plot a graph, IV graph, for both the boxes. So the graph in which there will be a straight line, that will be fixed resistor, and the graph whose IV graph will be a curve, that will be filament lamp, because the filament lamp is non-ohmic conductor. So the question, my answer is plot the graph of I versus V for both box whose IV graph is curve is filament lamp. So very easily you can recognize. So my dear students, by this question, we have reached the end of this paper. Let me show you that that is the question we were doing. So your question is over. Your paper is over. So, my dear students, by this question, we have reached the end of this paper. Today, we have solved May, June 2024 one paper. This was an ATP paper, and this paper belongs from the zone 1 or the variant 1. And I hope that by watching this video, you will be able to do this paper. If you it works in an excellent manner if you have a hard copy of that paper and you listen carefully and then you understand and then you write your own answers, and also make sure that you check the marking scheme. So that's it for today. It was a great pleasure teaching you all, and don't forget to subscribe to my YouTube channel. Also like this video. If you find this video helpful to you, to share this video in your Facebook and on the Instagram, because that will be a great appreciation for me, and it will be a great encouragement for me. So thank you very much, everybody, once again, and have a good weekend. So thank you very much. Have a good day. God bless you all.